Do you realize it's just as intellectually lazy to believe everything you see as it is to deny everything you see?
Yes.
Why should someone know automatically that Earth isn't flat, yet I tell them in the next breath that the entire universe was once as small as a marble? Both of those sound equally preposterous, except one has evidence to back it and the other does not, and very strong scientific, theoretical, and experimental underpinnings. So when you are trained to inquire, you don't either believe everything outright or reject everything outright. You're trained to ask questions. You're trained to probe deeper than the layer of information that comes to you. There was this rock in Antarctica and meteorite discovered, ALH 84001, which had tantalizing evidence. By the way, that rock was from Mars, one of the tonnage of rocks that we know are out there. And there was evidence in one of the nooks of that rock for possible life, traceable not to Earth but from Mars. And there was chemistry there that could only happen in the presence of oxygen, and there was chemistry there occupying a similar spot that could happen only in the absence of oxygen. So can we measure how ignorant we are? Perhaps. We know that what we do know about the universe comprises 4% of everything that drives it. 96% of what's driving this universe in the form of dark matter and dark energy, we have no idea.
How do you know that it's 4%? Because you haven't been able, have you, to measure what we don't know?
No, so that's a really cool question. In science, in astrophysics in particular, in all sciences, you have the capacity to measure something, even if you don't know what it is.
How so?
Well, so, for example, you could measure the fact that something is falling to the ground, but not know what it is or what's causing it or why. But you can measure it. You can measure the sun moving across the sky, build calendars based on that, and not even know that Earth goes around the sun. You can, and once you find out Earth goes around the sun, that flips your point of view, but it doesn't invalidate the concept of a year. You can make all manner of measurements and not know what's causing it. We measure this thing we're calling dark matter. We measure this phenomenon, dark energy, that's forcing the universe to accelerate. When you add up what we know with those two things about which we don't know what's driving them, we only know 4% of what's driving them. So that's humbling. Yeah. That's humbling. So I wonder if we're just blithering idiots in the presence of even a trivially smarter species than us. So therefore, who are we to even assert that, number one, we are intelligent and we're looking for others at least as intelligent as us out there to talk to? By the way, is there any other species on Earth that we can talk to? Can we have a conversation with a chimp? That has nearly identical DNA, and I don't think we can actually say, hey, what movie do you want to see tonight? You don't have that conversation with a chimp. Yet somehow we want to believe that an alien on another planet that's not even based on DNA, and even if it is, it's not nothing like us, that we could communicate with it.
Yeah.
That when we look out into the universe, we know we are connected to it because the very elements in our body are traceable to these stars that manufactured them, exploded, scattered them into the galaxy, out of which we form the stars and planets, even dwarf planets, on which you then find the ingredients for life. So we look up, we don't feel small, we actually feel quite large, because we are a participant in a much larger story than ourselves. You ever see the schoolroom globes, the geographic globes? And you rub your finger over Nepal and you get the Himalayas. Yeah, and you get the Rockies. And you say, oh, that is a gross exaggeration of reality.
Yes.
Do you realize if you took Earth with all of its mountains, valleys, and hills and shrunk it down to the size of a cue ball, it would be smoother than any cue ball ever machined.
Really?
Yes. Yes. In the original definition of planet is from the Greek planetes, meaning wanderer. And in ancient Greece, there were just 7 objects in the sky that wandered against the background sky. And there were only 7. And it was Mercury, Venus, Mars, Jupiter, Saturn, the sun, and the moon. And we traced the names of our 7 days of the week to those 7 objects through both Roman and here in the West, in Roman and Norse mythology. So Saturdays after Saturn, Sundays after the sun, Mondays after the moon, that sort of thing. So those are the 7 planets, unambiguously defined. No argument. Do you move? You're a planet. Period. So the way it works now is, to be a planet, you need to check in 2 boxes. The first box is, are you round? Okay? Actually, it's 3 checks. First, are you round? Well, Pluto's round. So there it goes, all right? Second check, are you the primary object that's in orbit around the sun? So you can't be a moon, even if you're round, and be called a planet. Got that? Gotcha. Okay. So the moon is not the primary object in our system going around the sun, so the moon, though round, would not be a planet in this. So Pluto, you get a check there. Pluto has a moon, a relatively big moon, but it still is the biggest in the system. So Pluto gets 2 checks.
And the third?
The third check. The third check is, have you cleared your orbit of orbital debris? And Pluto has not. It is in a crowded zone with countless other icy bodies in the outer solar system, the Kuiper belt of comets. So what's going on here is you're viewing the structure of the large-scale universe. And what we've represented here are dark areas that themselves have more gravitational attraction than the light areas. So the light areas are drawing themselves to the dark areas. And so what happens is, as this happens over the eons, structure begins to manifest in the universe. And you see this web work, and it looks almost organic, or it looks like some kind of neurosynaptic map. The formation and collection of matter in the universe follows the laws of physics, and when you add in the dark matter, this extra gravity, it turns the universe into the universe that we see. That's why we know the dark matter is real. We don't know what it is, but we know it's there because we can't make the universe as we see it unless we put this extra gravity into our simulations to match the gravity that we see. You multiply up the numbers, the stars in the galaxies in the universe. These are staggeringly huge numbers, 10 to the 21 stars, 1,000 times bigger than the number of grains of sand on an average beach. Itself, 100 times bigger than the number of words ever spoken or uttered by all humans who have ever lived. These are staggeringly large, stupendously large numbers, to use Richard's word, that give us the confidence that even if intelligent life is only short-lived, grows up and then it becomes so smart it can kill itself, that there's bound to be one out there that we're hitting it right at the right time, that they are happy to have a conversation with us if we're smart enough to have a conversation with them. Oh, the molecules and the atoms of those molecules in my body are traceable to stars across the galaxy that have lived their lives, manufactured these elements, exploded them into the universe, from which new generations of star systems were formed. So I look up at the night sky, I don't feel small, I feel large. I feel connected to the universe. It's not just we here on Earth, and that's there. We are one. 85% of the gravity of the universe has an unknown origin. We call it dark matter. We don't know what it is. Then there's some mysterious pressure acting opposite gravity that's making the universe accelerate in its expansion. We know we're in an expanding universe, and we also, by conventional physics, say that, well, we're expanding, but there's all these galaxies, and the collective gravity ought to be slowing down that expansion. The way you toss something up, take your shoe or ball and toss it up. Earth's gravity works on that upward speed and persistently slows it down. Eventually makes it stop and come back. We've known for a long time there's not enough gravity to stop the expansion, but any amount of gravity ought to be slowing it down, at least slowing it down. You look out there, an observation made 12 years ago, published 12 years ago, the universe is not slowing down, it's accelerating. It turns out Mars may have been wet, we know at some point it had water, and fertile for life before Earth. And at this period of heavy bombardment, if it had started life, surely it would have been simple life, there's no reason to think otherwise. We've learned that bacteria can be quite hardy, as you surely know. So we imagine a bacterial stowaway in the nooks and crannies of one of these rocks that are cast back into space. In fact, if you do the calculation, there's hundreds of tons of Mars rocks that should have fallen to Earth by now over the history of the solar system. Maybe one of those rocks carried life from Mars to Earth, seeding life on Earth. That now you look at the expanding universe and you find out it's accelerating. There's some anti-gravity pressure that's making the universe expand faster than the natural other forces would have it behave. We don't know what's causing that either. That's called dark energy. And dark energy is 94% of all the matter energy in the universe. So all the science, everything we ever talk about is contained within 4% of what the universe is. One of the great advances in exobiology was the discovery that life on Earth is hardier than anyone had ever previously given it credit. We no longer need the room temperature pond water to have life thrive. The more we've looked in the Earth, the more we've found life doing the backstroke under extraordinarily hostile conditions, hostile to humans, that is. What that has done for us astrophysically is allow us to cast for life with a much wider net than we had previously thought we had available to us. Whereas before we would look in the habitable zone, the Goldilocks zone, not too close to a host star, your water would evaporate, not too far away, water freezes. You're looking for that liquid water zone, made liquid by sunlight. We find out all you really need is an energy source, doesn't have to be the sun. Jupiter keeps Europa warm, one of its moons. It has a liquid ocean, it's been liquid for billions of years. You want to look for life, armed with this diversity of life, the hardiness of life, even we find here on Earth, it has only broadened our search for life in the cosmos. All evidence points to we're on a one-way trip to oblivion. So the universe expands, the temperature of the universe drops, all stars eventually will run out of fuel, so the stars, one by one in the night sky, will turn off. And in the extremely distant future, quadrillion years into the future, there'll be no light coming to us in the day or night sky. And because all stars would have died, and all gas clouds would have made stars that were going to make them, and there'd be no more new stars created. And so that the universe will end not with a bang, but with a whimper. And not in fire, but in ice. Life is just the extreme expression of complex chemistry. So that's what biology is. So all these people who want to imagine, because they remembered their chemistry class, that silicon sits right below carbon on the periodic table. So it bonds similarly to carbon, so they want to imagine silicon-based life. I'm saying, okay, fine, but you don't have to. There's 5 times as much carbon in the universe as silicon. There's no need to even have to go there. We got enough to imagine just simply with the carbon atom at the center of these huge biological molecules. Point is, it happened relatively quickly with the most common ingredients in the universe. To now say life on Earth is unique in the universe would be inexcusably egocentric. We used to have catalogs of galaxies. We said, that's a really messed up looking galaxy there. Let's make a catalog of irregular galaxies. So we have a catalog of beautiful galaxies and irregular galaxies. And then people came up with theories. How does a galaxy become irregular? No one knew until we realized galaxies collide. Galaxies feel each other's local gravity, collide, and it's a train wreck. And half the irregular galaxies are train wrecked galaxies. Now, how do you get to know that galaxies collide? You put in the forces of gravity on a computer, run the simulation, and watch it unfold. And there you can recreate the havoc that you see in the universe on 100 million year timescale.